familiar with the terms displacement, velocity, and acceleration. Okay, we know that there's a difference when it comes to certain, what it means by displacement. Okay, and that difference comes from the idea of scalar quantities and vector quantities. Alright, so for displacement, it is a vector quantity. What is the contrasting one? What is the contrast to displacement? Distance, right? And then after that, for velocity, the contrast would be speed. Okay, and then acceleration, there's no contrast, but we know that it is a vector quantity. Okay, so for vector quantity, we know that the direction matters. Okay, so that is the difference between the two. Okay. If you were to look at maybe a distance time or displacement time, okay, let me just loosely label it as S to represent either displacement or distance. Okay, then after that, for a VT graph, let me just loosely use V to either represent speed or velocity. Okay, we know that for a distance time or displacement time graph, okay, the only useful information out of the graph itself will only concern us for is the gradient. Alright, so the gradient in a displacement or distance time graph would actually tell you what? The speed if it is distance, or else it is the velocity if it is a displacement time graph. Right, so I'm just following the same corresponding kind of writing up. Okay. Then after that, for the velocity or VT graph, whereby V represents either speed or velocity depending on the situation, we know that for gradient, what would it tell us? It will just tell us acceleration, right, regardless. Okay. Then after that, if you're looking at area under the graph, okay, what would it tell us? The distance or the displacement, right? Okay, so as far as we have already covered our kinematics, our integration and differentiation, right? Okay, we know that one of the application for differentiation is actually gradient. So we are looking at differentiation whenever we do gradient. And then likewise, for area under the graph, okay, we will be looking at application of integration. So far. So all of these ideas we already know, right? Okay, it's nothing new, correct? So when it comes to scalar and vector, we know that vector, the direction matters. Okay, so usually we will take our positive values, okay, to either be we will take some conventions. Okay, for positive values, we will take convention to either traveling in the right direction, as in the right side, or outwards. Rightwards or outwards, yes. Okay, why do you think we decide to use such convention? Why do you think that we chose such convention? It would be consistent with certain things. Gravity goes downwards. Yeah. Have you ever wondered why do we stick such conventions? Because it is aligned with how we understand graphs, right? Okay, our graph, okay, we always see right side as positive, upwards as positive. So that's why, okay, naturally, okay, we will take such conventions as well. Okay, although I don't know whether this is the reason why the people in the olden days decide to have such convention, but I think that this is probably the reason. Okay. When it comes to displacement, okay, I don't go into definition. You'll not be asked to actually write down definition of displacement and all that, of course. It is a maths paper. Okay, but we need to understand when is it positive, when is it negative. Okay, so just now earlier we said that positive values means that it's traveling rightwards or upwards. Okay, so if we take a starting point at 0, okay, if we find that the value for displacement, which we usually denote with the letter S, okay, if it is more than 0, that means it is rightwards of the starting point. Then if it is negative, okay, then it will be actually leftwards of the starting point, right? Then after that, when it comes to velocity, okay, when the velocity is more than 0, okay, it will mean that it is moving rightwards, okay. So then after that, velocity less than 0 will mean that it is moving leftwards, okay. So it doesn't really tell us that it is slower or faster, okay. Slower or faster is being interpreted by what? The value itself. Okay, will tell you whether is it slower or faster, but the positive and negative when it comes to velocity wise, okay, it will tell you what direction is it actually moving. Okay, then after that, when v is equals to 0, what does that actually mean? Stationary, and what else? Change direction. Why do you say change direction?
Because we change direction, slow down.
Okay, so instantaneously at rest, right? Okay, so when v is equals to 0, it might refer to instantaneously at rest, meaning to say that it might actually be preparing itself to change direction. Alright?
we always assume that right is positive, left is negative? Or do you have to state it?
Do you all state it in physics?
Yeah.
Then just keep it, yeah, although I'm not particular about it. We will take that convention. Yeah, just keep that in view. I don't want to contradict your physics. But actually the question we usually they don't say. Yeah, but just keep that. Your friends were asking, do I have to state down what do you usually state in physics? Take upwards as positive, take rightwards as positive. Okay, that was what you're taught in physics. Okay, I think I don't want to contradict with what you learned in physics. You can keep that habit. Okay, write that in your answers. That is fine. But okay, in all my answers for this chapter, okay, I will not write that down. I will stick to the convention that I earlier said, that rightwards is positive or upwards is actually positive. Okay, usually in our cases, we are only looking at left or right lah. Okay, on the plain ground. We're not looking at going up or down. Alright, so usually it is right or left. So I will always assume that rightwards is positive, leftwards is negative. Okay. So let's look at try 1 first. Okay, we have a particle r moving in a straight line, so that its distance s meters from a point O, okay, is given by this particular equation. Okay, and then we're looking for the timeline from 0 to 4. Okay, first of all, the question actually says that distance. Okay, use the word distance to describe the letter s. Okay, but they actually don't really mean that it is distance, because it followed on to say that from a fixed point O. So actually what it refers to is displacement. Okay, because there is reference being taken from a particular point. Okay, so for most of our cases that we're looking at, we tend to be looking at displacement. We very rarely look at distance itself. Okay, so they always say that there is a reference point to take, so therefore it makes it a displacement rather than a distance. Okay, so please make sure you understand what the question actually refers to, rather than confusing yourself. So in part 1, we want to find out what is the speed of r after 1 second. Okay, so earlier on we said that in a distance time or displacement time graph, the gradient, which is the application of differentiation, would give you the speed, okay, or velocity. So therefore, to find out what is the speed, okay, we will want to find out what is the gradient, or rather the derivative from the equation of the displacement. Okay. So the velocity is the derivative ds over dt. Okay, although you need not write down ds over dt. Okay, you can write v equals to 12 minus 16, or ds over dt equals to 12 minus 16. So when the time is equals to 1, that's what we're looking at. The velocity will be 12 minus 6 times 1, that will be 6. Okay, so the velocity itself is positive 6, but the speed is just 6, because we are not concerning ourselves over the direction. So if the question were to end up in a situation where the value v is, for example, negative 6, it is just telling us that it is moving leftwards, the speed of r will still be a positive value, which is 6. This negative itself just tells us direction. But for speed, we do not need direction.
And what if they ask for velocity?
If they ask for velocity, then yeah, keep to the value that we have already found out. Okay? Because we know that this is displacement. And therefore this must be velocity. Okay? Am I confusing y'all? You understand what I'm saying? Or am I saying redundant things? Huh? Kind of lah. Okay. So you already understand this, is it? Because the people here are like sleeping already.
Took a better part of last
Okay.
Intern 2 marks lah.
Either 4 marks, is it?
a few weeks to get this.
You just wait as the FYE.
So we've already went through now.
Either can you wake up, please?
I think it's more for bio students. That's why everyone here is physics. So.
Okay, next part 2. We want to find the distance of r from O when the particle is instantaneously at rest again. Okay, so likewise the question actually says distance of r from O. So actually this refers to the displacement now. Okay, basically. Okay, so when the particle is instantaneously at rest, this keyword will tell you that we're looking at v equals to 0. Okay, so when v is equals to 0, the time t is equals to 2, and therefore to find out what is that displacement, so the displacement, okay, would be 12 meters. Questions up to here? Okay, part 3, we are trying to find the total distance travelled during the first 3 seconds. Okay, the question asks for total distance, not total displacement. So the things that are given to us is only displacement, okay, because they are relative to a fixed point O. Okay, so in this case, we need to understand the situation that has been unfolded for us in part 1 and 2. Okay, we found that in part 2 itself, there is a point whereby it is instantaneously at rest. Okay, just now we agreed that when it is instantaneously at rest, it might actually mean that it is changing in direction because it can't possibly be stopping. Okay, so in this case, we are looking at a starting point when t is equals to 0. And then at a particular point when t is equals to 2, there is this change in directions. Okay, and then after that at t equals to 3, we want to find the entire length, the entire distance, meaning from t equals to 0 to t equals to 2, what is that distance? And then after that from t equals 2 to t equals to 3, what is that displacement? Okay, are you following me so far? So from t equals to 0 to t equals to 2, right, we have already found in part 2 that it is 12 meters long. Okay, if I were to substitute in t equals to 3 into the displacement equation, I will be getting the value of 9. Okay, what this actually means is that relative from the starting point, okay, to this point when t equals to 3, this is actually 9 meters. You understand what I'm saying? Okay, so from the starting point to t equals to 2 where it turns, it is 12 meters, and then from starting point to t equals to 3 is 9 meters. But what I want to find is actually the total distance of travel, which means that it is 12 meters, and then adding up this part here also. Okay, so I need to find out what is the distance being travelled from t equals to 2 to t equals to 3. the total distance will be 12 plus 3 meters, so that will be 15 meters. Any questions? Exercise 20.1 question 9. So likewise, we are looking at a particle moving in a straight line. Okay, and then the question says that displacement from a fixed point is given as s meters. So this one is straightforward. Just know that s actually refers to displacement. Okay. Then after that, t seconds after passing O. Okay. So the equation that we have is this part over here. Okay. In part 1, we want to find out what is the acceleration when it comes instantaneously to rest. Instantaneously to rest, likewise as we said just now, refers to when v is equals to 0. Okay, now we are trying to find out what is the acceleration. Okay, we said that when we look at a velocity time graph, the gradient gives us the acceleration. So that means that we will need to differentiate the v, okay, for us to find out what is the acceleration. But we do not know what is the velocity now, or rather we do not know what's the equation for velocity, but we can find that out from the displacement equation. Because when we want to find the velocity, we actually differentiate the displacement equation, right? So the velocity equation would be 12 minus 3t squared. And then after that, find out the acceleration. That will be a equals to negative 60 by differentiating your velocity. Okay. And since you're looking at when it is instantaneously at rest, that means v is equals to 0. We find that we have to definitely reject the negative t value, so therefore it is when time is equal to 2. So therefore the acceleration would be negative 12, okay? So that will mean that it is negative 12 meters per second. note that for acceleration, right, how we interpret the positive, negative, and zero of acceleration, it is actually different. Okay, in this case, when acceleration is negative 12, it will actually mean that it is slowing down. Or decelerating. Okay, and then when it is actually positive, it means that it is speeding up. So actually the negative and positive of it doesn't really tell us the direction. Okay, it is only the negative and positive of the displacement and the velocity will tell us the direction. Okay. So when A equals to 0, what does it mean?
No acceleration.
No acceleration. Constant speed, right? Velocity of the particle when it is next at O, which is the original starting point. Okay, so at O itself, the displacement will have to be equals to what value? What would the displacement have to be? 0, right? Because the displacement is measured from the starting point. So at O itself, the displacement is equals to 0. So 12t minus t cubed will be equals to 0. Next at 0, so therefore we will definitely not be looking at when t is equals to 0. So we are only looking at when t is equals to square root 12. So the velocity will be negative 24 meters per second. The distance travelled during the first 3 seconds. So there is a starting point when t equals to 0, s is equals to 0. Okay, and then after that, in part 1, we actually found out when it actually comes to instantaneous rest. Okay, that is when t is equals to 2. So there is this change in direction. Okay, we know that there is a change. Okay, we can tell it because we can compare the displacement. Okay, which I'll do it later. So we want to find out up to t equals to 3. Okay. So when t equals to 2, the displacement would actually be 16. And when t equals to 3, the displacement is equals to 9. it doesn't make sense that after a longer time the displacement becomes shorter if they are actually traveling in the same direction. Alright? Okay, because if it continues, if this is supposed to be a stop, okay, and it continues, right, then this displacement value should actually be larger than 16 already. But because it is smaller than 16, therefore we can infer that there is actually a change in direction. So therefore, this is 9 meters and this is 16 meters. So therefore total distance will be 16 plus 16 minus 9. That will be 23 meters. Yes. No. Why do you need that? Then later again. No, at t equals 2, at instantaneous rest interval, t equals 2.1 can't possibly be the place where it turns. And why do you choose 2.1? Why not you tell me 2.00001? Okay? Because at t equals 2 itself, that is where the instantaneous rest is. Okay. Right, we will continue with this tomorrow.